Hey guys, so this next lesson is about something called bearings. And so basically, bearings are it's basically an angle that's used in navigation. And so, what we're going to do is we're going to solve some word problems by drawing a picture based on the bearings and then solving using like Pythagorean theorem or trig or law of sines, law of cosines. All right, so here we go. Okay, so these notes are on Classroom. If you were able to print them out, that's great. If not, that's fine too. So first of all, like I said, it says a bearing is an application involving triangles and navigation. So since it's involving navigation, why don't we draw a little compass in the top so we can, just in case you guys don't know your directions. So we have north, south, west, east. Then this would be northeast, northwest, southwest, southeast. So there are two different methods that we're going to use for bearings. Today we're going to do the first method, and the next time we'll do the second method. So the first method is when you're given a bearing with just a single angle, such as 164 degrees. And so what it would say in the problem is it would say that something is on a bearing of 164 degrees. So that's the first method. You're just given a single angle for your bearing. And so when you're given a single angle, every single time when you draw it, you're drawing it from north and you're going clockwise. So these are some examples of some different bearings. So like it always starts north and it goes clockwise. So that would be the angle for that one. This one starts north, goes clockwise, starts north, goes clockwise, starts north, goes clockwise. Now I'm going to estimate the measure of each of these bearings. I'm going to use a protractor. If you have a protractor, I would highly suggest that you use it. If you don't have one, then that's okay. You can just estimate when you're doing the pictures. It does make it a little bit easier with a protractor, but it's not the end of the world if you don't have one. Okay, so to estimate this one, first of all, I want to say that this vertical north line, every picture that you're going to draw is going to have one of these. That's called your bearing line. So when I say draw a bearing line, I just basically mean draw a vertical line. So if we're going to estimate this bearing, I'd say we're not going to be super exact. That's about 45 degrees. So this, if I were to draw this picture, the description would have said a bearing of 45 degrees. And that's what that would look like. Okay, let's see this one. I would say this one's about 135. Again, I'm not being super exact. We're just estimating. So that would say a bearing of 135 degrees. We could have also measured this angle from the 180 and subtracted it. That would have been 45. Okay. So over here, now this one, notice that this bearing, since it's coming from north and it's going clockwise, this one is greater than 180 degrees. So you can do this in a few different ways. You can either measure this angle and add it to the 180, or you can measure this way and subtract from 360 because the whole thing would be a circle. So I'm going to show you both methods. So if we put the protractor here, let's see, I would say this angle looks like it's just about 50 degrees and this angle is 130. So this one's 130. This one's about 50. So your two ways to measure this bearing would be either to do 360 minus 130. So think about this is 360 because it's one full rotation. So you're subtracting that part of it and that would give you 230. So that's the answer here. This bearing is 230 degrees. Another way is you could take from here to here is 180 and then from here to here is 50. So you could do 180 plus 50 would be 230. Either way, this bearing from here to here, we would say is 230 degrees. Same thing here. This one's probably a little bit easier just to measure this, but again, it doesn't matter if you wanted to do 180 plus this, you could. I'm just going to do subtract from 180. That's typically, I mean, from 360. That's typically what I do for these. So this angle here, as you can see, is about 70 degrees. So I would do 360 minus 70, which is 290. So this is a bearing of 290 degrees. Okay, so let's get into some actual examples of drawing them. So when you're drawing the pictures for the bearings, you just basically just like draw it in order of the problem. So this one says that radar stations A and B are on an east-west line 3.7 kilometers apart. So an east-west line means that we need a horizontal line. So let's say here's A and here's B, and they're 3.7 kilometers apart. Station A detects a plane at C on a bearing of 61 degrees. So off to the side, I often like to make a little list of all my bearings. So from A to C is 61 degrees. Then it says station B simultaneously detects the same plane on a bearing of 331 degrees. So B to C is 331. And so what we're going to do is we're going to draw each bearing from A to C and from B to C. And where they intersect, that's where our C is going to be. So in order to draw my bearing from A to C, I need a bearing line. So you're going to take your ruler. Your north bearing, since this is an east-west line, these would be perpendicular. This isn't always going to happen. Like you won't always have an east-west line necessarily. You'll see in the other examples. But if you do, your north line is always going to be perpendicular to an east-west line. So here's my bearing line. Here's north. Here's A. So it says that from A to C, we need a bearing of 61 degrees. So we need to measure 61 degrees that way. I'm going to grab my protractor. So 61 degrees is at about here. So I'm just going to connect. I'm not going to draw C on this line just yet because we don't quite know where it's going to be. I do know that this is 61 degrees. Okay, so next, so this one we already did. Now we're going to do from B to C is 331. So from B to C, we need a vertical bearing line. This time it's 331 degrees. So that means from here, from B, from north all the way around is going to be 331. So what I would suggest to do is for this one, do 360 minus 331, which is 29 degrees, and then just do 29 degrees that way. Okay, grab your protractor, or again, you can just estimate. Just make sure as you're drawing, the biggest thing with bearings is as you're drawing the picture and as you're making your bearings, label the angle. That's huge. So 29 degrees is about here. Okay, so I just so happened to stop at exactly where C is. That doesn't always happen. So there's your C. This angle is 29 degrees. Okay, so it says find the distance from A to C. Okay, a couple different things here. When you draw your picture, you then need to label any angles that you know that you can label. Since this is an east-west line, and these are both north-south lines, those are going to be perpendicular. So that makes this a right angle. I just want to say this is not going to happen in every single bearing problem, only if there's an east-west line and north-south line. So if this whole thing is 90 and this one is 61, 90 minus 61 is going to be 29. Notice over here, this one's 29, so from 90, this would be 61. Now we can find this angle, 29 plus 61 is 90, so that makes this one 90. So after you draw your picture, you're labeling all of the angles that you can. Now that I have all of the angles, I can very easily find X. Remember, we can use SOHCAHTOA for something like this. Because it's a right triangle, they won't always be a right triangle, but if there is a right triangle, you can use it. So you can use SOHCAHTOA. So you're going to pick either 29 degrees or 61 degrees. I'll pick 29. This is the hypotenuse rather, and this is adjacent. So A and H is cosine. So you would set up cosine to find X. It's going to be cosine of 29 equals adjacent, which is X, over hypotenuse, which is 3.7. And you're going to multiply both sides by 3.7. Okay, so 3.7 times cosine of 29 is approximately 3.24 kilometers. So this is the distance from A to B. A to C, rather. Okay, so there's our first example. You really just have to very carefully, step by step, from the beginning, draw the picture exactly how it says, and then find all the angles that you can find, and then solve. Okay, let's do the next one. So number 2, distance flown by a plane. So a plane flies 1.3 hours at 110 miles per hour on a bearing of 40 degrees. It then turns and flies 1.5 hours at the same speed on a bearing of 130. So you have a plane that has a starting point. It's flying on a bearing of 40 degrees. Then it turns, and we need another bearing of 130 degrees. Let's start by just drawing the picture first. So you have your start, and then it's a 40-degree bearing, and then it's a 130-degree bearing. We'll deal with the 1.3 hours and the 110. We can deal with that later. Let's just get the picture down. So for this one, there is no east-west line, so we don't have to worry about that. When you're just going to start a bearing, you need a vertical line. So let's make our vertical line. There's north. We're just going to pick any spot on that line. We look somewhere in the middle. This is where our plane is starting from. Okay, so we need a 40-degree bearing. So you're going to grab your protractor or just estimate approximately where 40 degrees would be. Remember, it's clockwise from north, so about here is 40 degrees. I'm going to push this down a little bit. Okay, so this is 40 degrees. Remember, as you draw, make sure you label. It says it then turns, so I just decided it's going to turn right here and go on a bearing of 130 degrees. So to draw another bearing, we're going to need another vertical bearing line. Anytime it says there's a bearing, you need a vertical bearing line. Okay, so now we need to notice, I should stop for a second, that these bearing lines are parallel. Any north-south lines will always be parallel. That'll come in after when we're trying to find the angles. Okay, so now from this point, after they turn, we want a bearing of 130 degrees. So again, you're going to grab your protractor, line it up. 130 degrees is from here now, so that would be about here. Or you could go 50 degrees this way also. Okay, so I'm going to connect here. So this is 130, and this would be 50. Label all the angles that you can. So we don't know exactly where to draw the stopping point, but the question's asking how far is it? So let's just say it's here from the starting point. So this distance here is what we're trying to find. How far is it from the starting point? So start, it goes, it turns. So how far apart are they? Okay, so to do this, we need to label some parts, some angles. Let's do the angles first, and then we'll deal with the sides. So notice, like I said, that these are parallel. So hopefully we notice that this 40-degree angle and this angle, those are alternate interior. So notice how 40 and 50, this is a 90-degree angle right here. Okay, this angle we cannot say is 50 because this is not an east-west line, so this is not a right angle. So that's really the only angle that we can find, but that's really all we need because now we know that we have a right triangle. And we can use Pythagorean theorem or SOHCAHTOA, whatever it is. Okay, the next thing we need to do is deal with the 1.3 hours at 110 miles per hour and then 1.5 at the same speed. So we're going to use the fact that distance equals rate times time. So for the first part, the 40-degree bearing, 1.3 hours at 110 miles per hour. So the rate is 110. times 1.3 miles, 1.3 hours rather, would give us 143 miles. So that was the 40-degree bearing. So that means that this part here, they were, like it says, they were going for 1.3 hours for 110 miles per hour before they turned. So this part is the 143 miles. Then they turned and they flew for 1.5 hours at the same speed. So this is going to be 110 times 1.5. Which is 165 miles. So this right here is 165. Okay, so now we have enough information to find x. There are two ways we can do it. We can either do Pythagorean theorem, or we can use trig. We can use SOHCAHTOA. I will show you the setup for Pythagorean theorem, and then I'm actually going to do it with trig. So for Pythagorean theorem, the x is your missing, so that's your c. So you'd have 143 squared plus 165 squared equals x squared. And then you'd solve for x. Or in order to use trig, you'd have to find one of the angles. Like, so I could find like this angle, let's say. Now keep in mind that we want to use this entire triangle. Let me highlight this in red. So this big triangle is the one that we want to focus on, because that's the right triangle. The other ones, we don't know if they're right triangles. So we have to focus on that red one. So what I'm going to do is I'm going to find, we'll call this y since we already had an x. We're going to find this angle. This is opposite the angle. This is adjacent to the angle. So you can do inverse tangent, 165 over 143, and get that y is approximately 49.1. So close to 50, but not exact. So once we have that, we can use regular trig to find x. So we could do like the 165 in x, that would be sine of 49.1 equals 165 over x, and then solve for x there. So multiply by x, divide by sine of 49.1. So either way, whether you do Pythagorean theorem or you solve it using trig, you would get that it's approximately 218.3. Okay, so the plane is 218.3 miles from its starting point. That would be your final answer. And I don't care if you do Pythagorean theorem. For a lot of you, that's probably easier, and you would think, like, why go through all of that if you could just do Pythagorean theorem? It doesn't matter either way. Okay, so that's number 2. We're going to do one more example together. Okay, here's number 3. So it says the bearing from C to B is 254. So I'm going to make a list of my bearings. C to B is 254. Then C to A. So notice C has 2 bearings from it. 344, B to A, 32. And then they give us a distance, A to C is 780 meters. Okay, so let's think about the C to B and the C to A are both almost 360. So you have to just kind of visualize it's going to be like all the way over here. So that means that our picture is most likely going to be on like the left-hand side of the bearing line. If you're ever unsure about where to put your bearing line, just putting it in the middle of the workspace is fine, because then you have room on the left and the right if you're not sure where to start. Let me finish reading. Sorry. It says find all missing. So we're going to find all the missing angles and the missing sides. So I have to start off with the bearing line. I'm going to do my C first. I tend to just like to do it in order. So however it's listed in the problem, that's the order that I draw it in. So I'm going to do C to B first. So in order to do that, I need my bearing line. And you should just pick a spot for C. Doesn't really matter where. So from C to B is 254. So if I do 360 minus 254, that's going to give me 106. So I'm going to go 106 degrees this way because the 254 is coming all the way around like that. Okay, so I've got my protractor. 106 is, oh, over here. 106 is like here. Right? Yeah. Okay, so here's my 106. You want to label as you go, like I said. So this is 106. This is 74. Might as well just label everything. Okay, so B is going to be somewhere down here. Then it says C to A is 344. So 360 minus 344 would be 16. So now I need a 16-degree angle that way to go to A. So here is 10, 15, 16 like here. Okay, so just this little sliver is 16. Let's think about if this is 16 and this whole thing is 106, that would make this part 90. Okay, so A is going to be somewhere up here. Actually, we're not going to put A yet. You know why? Because it says B to A is 32. So where these two intersect, the C to A and the B to A, that's where A will be. So in order to find where A is, I need to do this last one. B to A is 32 degrees. So I need a vertical bearing line through B. And we need 32 degrees, and that's clockwise, remember? So I'm going to set up my protractor. So 32 degrees would be about here. And so now this is going to connect to the other line, which I'm going to have to extend a little bit, but that's okay. So here's where A would be. Let me erase some of this. Okay, so I didn't label the angle just then. That was 32 degrees would be here. Okay, so that's 32 degrees. What else do we know? We know A to C, this right here is 780. Okay, let's try to label some angles here. These are parallel. So remember, let's say like this, if this whole angle is 106, remember that whole angle and this whole angle are considered to be consecutive interior. So this whole angle would be 74, making this one 42. So you just have to like really use everything that we've learned. Well, not everything, but a lot of things that we've learned this year to figure this out. So pay attention to like your consecutive interior angles, your alternate interior angles, stuff like that. So this whole thing is 74 because this whole thing is 106. Also, you could think of this and this are alternate interior. You could have done it that way too. And 74 minus 32 is 42. So we have 42. We have this is 90. I'm going to erase this 106 now since we don't really need it. So this up here would be 48 because 90 minus 42 is 48. Okay, so we have all three angles. So when it says find all the missing parts of the triangular area, we're talking about this triangle here. Okay, so the only two things left to find are the two sides. So we'll label those X and Y. And now we can just use SOHCAHTOA. So I'm going to use the 48-degree angle. This is opposite. This is adjacent. This is hypotenuse. So to find Y, we can do tangent. So tangent of 48 equals Y over 780. Multiply both sides by 780 to get that Y is about 866.28. And this is meters. So that's from B to C. Okay, and then for X, we can do cosine. I'm going to go back and use the 780. So it's going to be cosine of 48 equals 780 over X. Multiply both sides by X. Divide by cosine of 48. So you're going to have 780 divided by cosine of 48. which is 1,165.69. And that's from D-Day. Whoops, I just realized you can't see anything I'm doing. I'm sorry about that. So then there is the last part. So we have successfully solved for all the interior angles. We have 42, we have 48, we have 90, and then we found all of the sides. Okay, so that's how you set up bearings. Just make sure that when you're practicing, just take it one step at a time. Draw your picture. I'll post the answers so you can compare to see if you're doing okay. And if you need some help, of course, you can join the live session. I'm going to do it at 1 o'clock. All right, that's it. Have a great day.